Hello and welcome everybody to our today's compact webinar from the Minivia Intech Academy. My name is Michael Meyer and today I am having the role as a host. But usually I'm trainer at the Minivia Intech Academy, and some of you I already see on the list should know me very well from your last training, so I'm happy to see you again. In my role as a host, I would like to do the introduction of the tool we are using today so you have the best experience possible. And I think the most obvious you should have recognized by now is your microphones are all muted. And this is by purpose. Yes, we have promised during the invitation that there will be a discussion with our speaker for today. So I would like to invite you to find out the Q&A section we have in the bottom of the tool. Make sure to send us your questions, and not only two of our colleagues are sitting in the background to answer your questions immediately, but on top we will also discuss the questions together with our speaker today. Second thing I would like to mention before we start is that in the GoToWebinar tool you're having in front of you, you can easily individually set up the view you have. So you can decide if you would like to see the speaker, the power presentation individually. So make sure you find out the buttons and you set up the screen at your wish. If you have two screens, you even can split the speaker and the presentation. I guess if you have this opportunity, it's the best view you can choose. Last point before we start, we have planned approximately of 25-30 minutes of presentation, and later on the Q&A session will take approximately 15 minutes. So we will be happy to meet your questions there. So I guess you are not here to listen to the host. I guess you're waiting for the speaker. Lena, thank you very much for joining us today. Welcome.
Thank you, Michael. I'm happy to be here.
Yeah, welcome. Thank you also for joining us with your very interesting topic in the field of industrial scales. And I guess stage is yours.
Thank you. Yeah, hello. My name is Lena Silius. I'm working in product management for industrial scales. And I want to talk today about how to obtain reliable counting results by using industrial scales. So let me show you first the agenda. The agenda will be, the first point will be the introduction. Afterwards, we will come to counting with industrial scales. Then following a theoretical background, the next step will be how I will show you how to choose the right counting scale. And then in the end, I will give you a live example of a counting scale. So first, starting with an introduction, which will be short. And there I want to show you the fields of applications where counting scales are used. These are, of course, in the incoming and outgoing inspection, in production, warehousing, packaging, and shipping. So let's begin with counting with industrial scales. What's the purpose of counting with industrial scales is to count a number of unknown parts or to count to a specific target. For this, the parts that you want to count have to have approximately an equal weight. Here on this file, we can see an example. We are having screws, and for determining the number of screws, we need a reference weight, so a reference quantity. With this reference quantity, the average piece weight of a part is determined, and afterwards you can count your parts. So I will start with a short example. So we have the screws where we have a target, for example, to count 1,000 pieces, and we have a piece weight of 1.3 gram per screw. Now I already said we need a reference piece quantity. I now selected a reference piece quantity of 10. So the weight of the reference quantity is 13 grams. So you take 1.3 gram times 10, which is then 13 grams. I think this is quite obvious. So coming to the basic principles of the counting scales, we need some equations. So as I said in the first step, we have to calculate the weight of the individual part. So we take the weight of the reference quantity and divide it by the pieces of the reference quantity. So the weight of the reference quantity was 13 grams and the pieces were 10. So we now know the weight of an individual part is 1.3 gram. Now we want to calculate how much parts we have. So we take the weight of all parts, which is 1,300 grams, divided by this 1 gram, and then we know, now when we've reached 1,300 grams, we have 1,000 pieces of screws. When you want to have this in one equation, you can put W1, so the weight of an individual part, into this equation, and you get this equation you can see in the bottom, which is the weight of all part times the pieces of the reference quantity divided by the weight of the reference quantity. This is the basic formula which is used for counting with industrial scales. So next thing, which is the basic point of this presentation, is, can I trust this weighing result? So am I sure that these are really 1,000 pieces, or is it maybe 995 pieces or 1,002 pieces? And to be sure, I show you now which influence factors we have that are affecting this counting result, and to show you how you can minimize the counting error. So I'm a little bit unfortunate because there is a theoretical background where we will have some equations. I hope you will stay with us and not be too shocked of the equations you will see, but I will start, and I hope I can explain it simple. So in principle, there are 6 influencing factors that causes counting errors on scale, which I want to present to you. The first one is the variance of the weight of the individual part. The second one is the variance of the weight of the reference quantity. The third one is the variance of the weight of the total number of pieces. So the total number of the weight of the total number of pieces were, in our example, the 1,300 grams. And for example, the weight of the individual part were the 1.3 grams, and the weight of the reference quantity were the 13 grams. So the first influencing factor is the number of parts to be counted. This was, in our example, the 1,000 pieces. This has an influence on the counting result, as for example, 100 pieces to be counted have a different influence. Then we have the reference quantity, which was, in our example, it had a size of 10. And then we have the average individual weight of a part, or the mean value of the individual weight. So I've talked now a lot of the variance of the weight. You saw that in the first 3 influence factors, there was written the variance of the weight. The variance of the weight is the difference in weight of individual measurements. So when you take, for example, a measurement series of 6 measurements, the difference in weight of this is the variance of the weight. So this is called the statistical variance, and it is described mathematically by the standard deviation of the individual part. We can see the formula for this here at the top. You don't have to keep this formula in mind. I just wanted to show it to you, as this is the equation for the standard deviation. What's more important, and I think a little bit more visual, is this one, because the standard deviation is used to calculate the scatter range of the individual values. This means all the 6 measurements that I took in an example are within this curve. And the standard deviation, for example, we see here, this is the mean value, and then we have our mean value, and the standard deviation shows how big the scatter range is. For example, when we take the mean value plus the standard deviation and the mean value minus the standard deviation, all our measurement series, 68% of our measurements are within this measurement, within this scatter range. So this 68.3% is the statistical certainty. And another example is, for example, that when we have a statistical certainty of 99.7%, so when we want to be sure that 99.7% of our measurements are within the scatter range of our mean value, we have to take the mean value minus 3 times the standard deviation and the mean value plus 3 times the standard deviation. Now, if you want to calculate the scatter range a little bit easier, you can take the delta x, how it is called, this is there, the standard deviation is multiplied with the t-factor or the student factor. The student or d-factor depends on the statistical certainty. So I have an example, the t-value is 2.57 when we have a statistical certainty of 95.4%. I know this is now very theoretically, and for that reason I brought an example. So we see now here a measurement of 6 values, where these all are lying around 1.3 gram. We can see this here, and also the mean value is 1.3 grams. So don't be scared of the formula. In the first step, we calculated the standard deviation, which is 0.001 gram, and then we, with the standard deviation, we could calculate delta x using the t-factor, which I explained, and the t-factor is depends on the statistical certainty, and we now said, yeah, we want a certainty of 95.4%, and so delta x is 2.57 times 0.001, which makes delta x of 0.003. So we have a scatter range that is from 1.297 gram to 1.303 gram. I hope this came out now a little bit clearer from this example. And in contrast to that, I also brought another example where we have the same mean value as you can see here, but the weights are totally different. You see this, sometimes it's 1.5 gram and sometimes it's 0.8 gram. And there the standard deviation that you calculate was 0.522 grams, so extremely higher. When we now multiply this again with the t-factor, we get the delta x, and we can calculate the scatter range. So the scatter range in this example is then from 0 to 2.64 grams. I think it's very obvious that with this different individual part weights, it's not possible to count correctly. And now that you know that, I want to go into detail of these 6 influencing factors. So starting with the variance of the weight of the individual part. The variance of the weight of the individual part has the biggest influence on the counting accuracy. So I now used the word counting accuracy. There's also a formula behind that. Before I show it to you, I want to say that we have a tool where you can put your reference quantity, for example, you can put the number of parts that you want to calculate and your piece weight, and then it determines how big your counting error is. So you don't have to keep the formula. I will show you in mind, because this is the formula. It's a little bit complicated, but when you take a closer look, it's not as complicated, because what you can see in this formula is every influencing factor that I explained to you. This is, I think, pretty obvious. What I want to focus in the first step is the 3 variances of the weight. The one was the variance of the weight of the individual part. Then we had the variance of the weight of the reference weight. And then we had the variance of the weight of the total weight. So the individual weight was 1.3 grams. This was 1 screw. Then we had the reference weight, which was 13 grams. These were 10 screws. And then we have the total weight, which were 1,000 screws, which are 1,300 grams. What you now can see is that each of them, all of these 3 are added, but they have a factor in front of it. So, and when we take a closer look on this factor in front of the statistical deviations here, there's the biggest of these factors is the factor for the individual piece variance, and then the variance of the reference weight, and then the variance of the total weight. And this comes more clearer when you look at it in a graph. So for example, when we have a reference quantity of 100, this is like here, then the factor which we put in front in this equation is about 10,000. When we take the variance of the reference weight, the factor is about 100, and the variance of the total weight is always 1, as the factor is only 1 in front. So we see, that this has a high that the variance of the individual piece has a big influence on the counting result. So the second influence is the variance of the weight of the reference quantity, and this is what I've already shown you, that this has also a big influence, but the influence of the individual piece variance is by far higher. And the last variance of the weight is the variance of the weight of the total number of pieces, and this is always 1 and has the least influence on the counting accuracy. So coming to we are now done with the variances of the weight, and we're now coming to the number of parts to be counted. So, and the smaller the total number of parts you want to count, the larger is the relative counting error. For that, I also brought an example. So you can see here again a graph, and I just took an example from the average individual part, a standard deviation of 3%, and a reference quantity of 100. So we are looking at the purple lines. And when I want to count 10,000 pieces, my counting error is 1%. And if I want to count 1,000 pieces, my counting error is 1.1%. And if I want to count 100 pieces, my counting error is 1.4%. In absolute numbers, this means when I want to count 10,000 pieces, the counting error is plus minus 100 in absolute numbers. For 100 pieces, it's in absolute numbers a counting error of plus minus 1.4 pieces. So in relative numbers, this can be higher, but in absolute numbers, this differs. So next influencing factor is the reference quantity. And yeah, the higher the reference quantity, the lower is the relative counting error. And also for that, I brought an example. And there I again took the same standard deviation of the individual part, so of the screws, which is 3%. And in this example, we want to count 10,000 pieces. And for when we have a reference quantity, in this case of 500 pieces, the counting error is just 0.5%. If I take 100 pieces of reference quantity, we already have a counting error of 1.1%. And if I only use 50 pieces of reference quantity, I have an error of 1.6%. And if you decide to have only 10 pieces of reference quantity, the error is 4.5%. So again, in absolute numbers, for 10 pieces of reference quantity, this means 1,000 pieces plus minus 450 pieces. So this is a really high counting error you have. And for 500 pieces of reference quantity, you have a counting error of 0.5%, which is a counting error of 50 pieces. So we see there's a difference of 400 pieces. You maybe now think, oh, 500 pieces reference quantity, this is hard to count for someone. But I will show you in the end how you can calculate the or how to get easily to the 500 pieces of reference quantity. So last but not least influencing factor is the average individual weight of a part. The average weight of an individual part is set into relation of the readability of the scale. The higher the readability, or respective the digit of a scale, the lower the relative counting error. So for example, when we have a readability of 1 gram, we have 1 digit. If we have a readability of 0.1 gram, we have a readability of 10 digits, and so on. So this is depending on the resolution on the scale of the scale. So on the left-hand side, we see now a graph where we have a readability of 1 digit. And on the right-hand side, you see a graph where we have a readability of 10 digits. In both cases, we want to count 10,000 parts again. And yeah, we are looking at the same standard deviation of a single part of 3%. And there we have, for just 1 digit, a counting error of 6.7%. And for a reference quantity of 50 pieces, sorry. And when we look in the other graph, we also again have 3% standard deviation, and look at the reference quantity here of 50. Here we looked at 50, and here also, and there we have then a counting error of 1.7%. So when we again put this into a relation, if we have 1 digit, we have a counting error of 670 pieces, which is really, really high. And when you have a scale with a better resolution, you have a counting error of just 170 pieces, which is a difference of 500 pieces. So this was my theoretical background, and now I'm coming to how you can select the right counting scale for you. And there I'm coming back to my example that we had at the start. So we want to count 1,000 pieces. We have an average weight of a screw of 1.3 gram, and we want to have a counting error that is equal or less than 0.05%, which means that we have an absolute deviation of 0.5 pieces, so that we can count to 1 piece exact. For that, I have calculated the reference quantity that we need, and I have calculated the digits we need. This can be done also by the Excel tool. I already said that I already mentioned. Sorry, and you can ask the Academy at academy@minebeaintech.com for this tool. They will send it to you starting from next week on. So in the first step, when we now have set our factors or our bases, we have to determine the capacity of the scale. So we have to know what will be the total load of the scale. So we have the 1.3 gram, which is the total load of the screws, plus, for example, 0.3 gram for a container where it should come in, which makes 1.6 kg. And then you have to choose a capacity where you have a little bit of buffer, so it would be a capacity of 3 gram. Then in the next step, you have to determine the resolution of a scale. And 3 gram are 3 kg, sorry, are 3,000 grams. This then has to be divided by the readability that we want to have, which is 0.01 gram, and then we have the resolution of 30,000 D. The next thing would be to determine the size of the platform. So you have to look what size of container you have. In my example, I just put 15 times 10 centimeters, and so the platform size just should be bigger. Next thing I want to talk about is a contrast. So on the one hand, we have a professional counting scale. On the other hand, we have a simple scale. And I just kept the same basis that we had before in the example. We want to count 1,000 pieces. We have an average weight of the screw of 1.3 gram, and we have a reference quantity of 60 pieces. So with our professional counting scale, we have a readability of 0.01 gram or 100 digit. And by that, we have a counting error of 0.05%, which is an absolute, what I already said, of 1,000 pieces plus minus 0.5. In the other example, we have a readability of 1 gram, which is a digit of is 1 digit, and there we have a counting error of 3.31%, which are approximately 1,000 pieces plus minus 33 pieces. So we see there's a huge impact of the resolution on the counting error. So, and as I promised you, I will say something how to easily get a high or come to a high number of reference quantity. Because without, I already said, it can easily come that you have a systematical error, so that somebody just counts incorrect. In this case, you can set a low reference stock level and then gradually increase it. So for example, you put 10 pieces on the scale and say, this is my reference quantity, and then you can put more screws in there, and the reference quantity, the reference weight is recalculated in each step. For this, you just have to follow one rule, and this is, when I have in my example, I had 10, so it has to be 2 times bigger. So I have to have at least 12 and to a maximum of 20. So I can put on the scale 2 to 8 screws. And this is then called the automatic piece weight optimization. I'm having an example for it, and we will also see it in the live example that I will show you at the end of the presentation. So here we can have again a graph where we have want to count 1,000 pieces, and we have a standard deviation of 1%. We want to have a counting error of 0.5%, and as you can see here, for that reason, we need 80 pieces of reference quantity. So 80 is now already a high number to count. So in the first step, we take 10 pieces of reference quantity. There we have an error of a little bit lower than 3%, but 3% of 10 is 0.3 pieces. So we are still counting correctly. This is very important, that you are all the time counting correctly. So the scale counts correctly, not you. Then we double this to 20, so we put 10 more in there, and there the error is then 1.5%. The reference the piece weight, the reference piece weight is calculated again. Then this is doubled. We have a reference quantity of 40. The piece weight is calculated again, and then we double it, and we are at our reference quantity of 80. But you don't have to exactly double, but you can just also estimate how much you have. You just don't have to be higher than double the size and have to be at least 2 more. So this is the automatic piece weight optimization. So I want to give a short summary. So what you have to keep in mind. These are in basic 4 points. The first one is the individual part of the weight has to be equal. This is very, very important. Another point is that you have to fit the reference quantity to your other counting requirements. And the readability has a really high impact on the counting result. And if you have a high reference quantity, it really makes sense to have an automatic piece weight optimization. All of our scales have an automatic piece weight optimization. Yes, and this is the point where I want to come to my live example. And I hope this works now. Yes, it does. Michael said you can just see me on the picture. I think this would now be good, because the presentation will not change. So we have here our Piro count scale, where we have here a display where you see the pieces counted. Here is the total weight, and in this display you can see the piece weight. So in the first step, I have my container. I tear it. I already did some work and counted 10 pieces. So I put my 10 pieces in here. I said, these are 10. Say, this is my sample. And there you see he calculated the piece weight. And now, I have to put at least 2 in, but I just grabbed some. I know these are not 10. Put them in. And as you see, hopefully, he adjusted the piece weight by auto optimization. It's also written below there. So this, and again, he adjusts it, and like this now, we can put our pieces. So, and he again adjusted it. So, coming back here, I want to thank you for your attention, and I'm happy to hear some questions that you have. And yeah, Michael, are there any questions that came in?
Thank you, Lena. Thank you very much for your presentation and also the live demonstration at the end. We have not received many questions, but still, let me start with a question which is meant to be for the host of today's presentation. So the question about your presentation, if we can share the presentation. It's something I mentioned during the chat. Yes, you can have the presentation if you want. Just give us a small message in the chat and we will make sure to send you the presentation after the event via email. So, Lena, let's come to the question and maybe let's start with the first one I have here. We have not many today, but still, the Signum scale, you have mentioned the Signum scale. Have it an automated piece weight optimization too, like the one you have shown on the Puro probably?
Yes, all of our scales, so the Midrix scales, the Combix scales, and the Puro scale have the automatic piece weight optimization. When you think of the Combix and the Signum and Midrix scales, you have to look for sure that you have the counting application on the scale. So this is important.
Okay, thank you very much, Lena, for this. Next question, can I also combine the counting application with other applications?
Yes, of course, you can combine, for example, the counting application with the check weighing application. This is often used, especially with the Puro count. There we also have check weighing LEDs, which show if you are too high or too low. So it checks when you put, for example, you can set two limits. One is 20 pieces. This is my lowest minimum. And then I have, for example, 50 pieces, which is my highest maximum. And then it indicates when you are between 20 and 50, then the check weighing LED turns green. And when you are above, it shows red, which is high. And when you are below the 20, it shows that you are too low. So this is what you can do with the Puro, and also with the other, with the Signum and Midrix and Combix, they can combine this applications. And still with the Combix, you can also add the totalization function, so you can have 3 applications combined, for example, check weighing, counting, and totalizing, which is
yeah, sounds great to me. Let me just check. So it looks like we are approaching the last questions. I get some messages asking for the presentation, and okay, but let's say this way, before we start with the last question for today, if you have any questions coming up, maybe after the event, feel free to contact us via email. So it's academy@minibea-intech.com. Ask your question very easily, and we will come back also at this at the later stage. So Lena, last question for you today.
Yeah.
If I want to count 3,000 pieces and the weight of one part is 12 grams, what reference quantity would you recommend or do the customer need?
Good question. There's some calculations behind it, so I can't answer this directly. But as I said in the webinar, we have a tool where you can calculate this, or where you can look which reference quantity you would need and which counting error you have. And this tool is then available from the Academy. So you just write an email to the Academy, academy@minibea-intech.com, and they will send you the tool by beginning of next week.
Great. One more reason to contact us. Thank you very much, everybody, for joining. Especially thank you, Lena, for joining us with your presentation today. Hope to see you soon again. And yeah, then I would say Goodbye, everybody. Stay safe and join us again. Oh, maybe one
Thanks,
last.
Michael.
If you would like to join more webinars from us, just
Yeah.
make sure you check on our homepage. There is a section for webinars, and you will not only find the recording of our last webinars, and in 2 days also the recording of this webinar, but you will also find the webinars we will have in future. So just check out on the homepage, minibeerintake.com, under the section for webinars, and join us for further events. We would be happy to see you soon. Thank you very much, and
Thank you.
goodbye, everybody.
Goodbye. Hallo. Sehr gut, war doch ein bisschen schneller als gedacht. Ich glaube, ich habe ganz schön schnell geredet. Man sieht mich noch. Okay. Ja, jetzt bin ich weg.